Hello everybody and welcome back to Beltmatic. In between episodes here I did fix up this quadruple multiplier just a little bit. So now it produces, I'd say it produces some full belt of things. It just every now and then gets these mishaps where it doesn't produce. But yeah, I think we have a full belt, and I'm really proud of this guy here, except for the fact that it every now and then does a tiny mistake over here. Let's regret that, and let's check why are we... okay, this is what's happening here. No, we don't want to do that. We want to cut that out and do this and that. Okay, yes, now we're happy. Yeah, how are we doing on the tasks? For those of you that haven't seen this game before, it's basically Shapez, but with math. And yeah, that's the thing. Next thing we are unlocking is the divider. I can't really see why that would be specifically helpful, because all of the numbers we are having to make are just growing and growing and growing, so I can't really see the benefit of that. But maybe it's something to care about in the future. Now, let's try to find another number to work on. So, 466. That's probably divisible by... it's at least divisible by 2. That makes 233, and that's probably not divisible by any other numbers that are called to divide with. 16 is not a number that can be divided by 3, so we can't make that happen. We probably need to... yeah, we just do it in 2 operations, dummy. Let's make 450. That's 9 times 5 times 5 times 2. So let's find some place where there are 9s and 5s. Yeah, and that's just add 16 to that later. 9 5s and 2s. 9 5s and 2s. They are very here. So we bring you, and you. Doop doop doop. For those of you who haven't seen this before, this is my quadruple multiplication unit. It takes in four numbers into these different kinds of tendrils here, and they multiply them together. So we are trying to make 25 times 18 here, which should produce 450. I hope. Yes, and then we need to basically add 16 on top of that, which we can make by... we can do it in a really stupid way. Yeah, let's do it in a really stupid way. Let's do this and just make this 2 here produce 16. That's silly, but I like silly every now and then. Then we need one of these multiplication units. No, addition units, I mean. They are going to take in 450 over here. They're gonna take in 16 over here. And they're gonna add those together, produce 466. And then we just need to deliver that to the processing units. We can deliver them over here, for example. That, and it's over there. Let's bring it around like this. Oh, we need to change the sounds. And like that. And now we should be producing 466. Yes, we are. Okay. And we can upgrade subtractor levels, so let's just do that. Now we are subtracting at a much higher pace than we used to do. Okay, we are doing this, 347. So yeah, we are already delivering those. We don't need to stress. I guess 670 is the only thing here we aren't currently producing. Are we delivering 36? I think we've been stuck at 2K for a while now. I don't know 36, no 36, no 36. I don't think we are delivering 36s anymore. We probably stole the belt at some point. Ooh, upgrades. Thank you. Okay, let's multiply with close proximity numbers here. We steal the... Oh, some 36s are coming in over here. So 18s, and at some point they are... Ah, okay, I see what's happening. So we need to change the priority there. Yeah, because we have too many 18s. No, okay. No pressure. Okay. We need to figure out a way to make... Or are we close at the new task? We still have a little bit more to deliver. We are doing these guys. They just haven't started delivering here. They are coming in here in a while. We need 670. 670. That's 67 times 10. But I don't think that helps us too much, because we need to make 67 somehow. Is 67 a prime? I think it's a prime, so we can't really multiply into that. But we can also maybe just multiply with 5 somehow. That's 135 times 5. No, I need to actually math on that. My brain is a little bit cooked right now. 134 times 5. 134. That's basically 67 times 2 again, because of course we are basically just doing 67 times 5 times 2 again. Yes, I'm stupid. I shouldn't have mathed that. We could do 64 times 10. That's 8852. That's decently easy, and then we add 30 on that later. So we need 2s, 5s, and 8s nearby. We could easily do that, and then we need to do addition after that. That's not something we need to worry about. The first thing first. Okay, 8s, 8s, 5s, and 2s. 8s, 5s, and 2s. Yes. 8, 5, and 2. So you are gonna deliver to 2 of these. Actually, I rather want to have this 8, because then we can have a easier blueprint to copy in the future. You're going over here. You're going over here. Yeah, okay. And you are coming up here, over there, and down there. So this is 640. Then we need to find 30 somehow, which basically we take just this part and place it next to these 5s and 6s over here. Extractors. Roop. And then we need to do addition again. Like so. You guys are going over here, you guys are coming over here, and that's 670. And now we just need to bring you down over here and find somewhere to put you into this thing. Are we still utilizing 16? We are no longer in the need for 16, so we can replace this belt. So let's do that, and do this, and we should be good for delivering those as well. Okay. Now we are now producing all of the numbers here except 636. That one is decent easy. That's 106 times 6, so we can easily do that. But we're also really close to finishing 506, and we do know what the next number is. It's 664. So 664 is basically 600 plus 600 plus 8 times 8. Yeah, let's just find a way to make a similar thing as this here. No, not as this thing was again. So we want a place where we can make 600 and where we can make 64. So here are two. No, we want this thing again. No, we want this thing again. Yes, because we want to add 8 here. Remove this thing. Oh, this one is so sad and boring. Let's do this instead. Okay, so this is 64. Now we need to make 600. And 600 is like 10, 10, 3, 2. It's at least very achievable. Are there 10s nearby? We can't harvest 11s, so in theory it should be a 10 around somewhere. I don't see any 10s. Or we could do 20 times 12. No, that's wrong. Anyway, we need 6s because that's. Wait, 6 might not be the correct thing. We could do 203. Let's look. Are the 10s nearby? I can't see any 10s. It probably is a 10 nearby. I just can't see it. Or maybe 10s are like stuff they don't want you to have because they make the game too easy. Maybe. Oh well, we'll have to make our own 10s. Okay, so so 2s and 5s are 10s. That means we need to make 60 with the remainder thing, which is easy. It's 6 and 10. Yeah. Maybe instead we do 30 and 4. 30 times 20. I mean, so you deliver over there. Instead of this 2, we find a 4, and a 4 is over here. Don't worry, we it took a while, but we got there in the end. And yeah, we are making some wrong numbers here, so we're making 300s because we did deliver 2s initially, but that is going to be fixed in a short while. Okay, let's do there. Okay, and they're going to be produced 600, add 64, and we have to wait for a long while until it gets delivered down, but it's going to happen. And we can deliver it into here somewhere. I don't think we need trees anymore, like the British said in the Middle Ages. And I'm sorry, that was a bad joke. There's that delivered. Okay, so that was the level task. Maybe we should double down on that to deliver it faster, since it's so far away. But we are making the correct product, so we shouldn't need to worry about that. It's gonna take a while until it fills out properly, but it's gonna make an entire belt. Then we need to make 636, and we said that's 106 times 6. 106, that's basically 53. 53 is a prime, so we can't easily make that. Maybe we just do the same thing where we make 600 and then add 36. That's probably the easiest thing to do, so we just build the entire thing here again. And we can even do it next to here, because we already know where a lot of these numbers are. So let's see, we need to find another 6. For example, this one. No, we can't build it right there. Let's build it upside down. Let's just build it over. Let's build it here like that. And don't stress too much about the fact that we have to build some more belts. It's a 3 builder game, so we can afford to build belts the way that we choose to. Okay, and then we make 600 again with the stuff we have available to us over here. You go there. You go there. And this thing will produce even more 5s. I think he can freely produce a lot more lanes than this. He can freely produce enough for 6 belts. So yeah, now we are producing 636 here. It just needs to arrive. So let's also find a way to deliver this. Bring it all the way down here. And ooh, there's actually a free belt up there. Okay, cool. Let's take this upgrade. This is even faster belt speed. Yes, we're gonna need that because we need to deliver faster. Woo, everything is 25% faster. Cool. No, 20% faster. Okay, 899. That's probably going to be 900 minus 1. Ooh, deliver 96 numbers per second. Okay, and upgrade multiplier levels as well. Awesome. Yeah, let's work on this thing first. 900 minus 1. That's probably going to be like again, I'm just looking for tens because everything would be just so much easier if there existed tens. But I think it's by design. There are no tens nearby, so yeah. That's fine. Okay, 899. So there are 11s and 9. That's 99. So we can produce 800, which we can get in tons of different ways. So maybe that's the thing. We make one of these machines, and we make 11 and 9 over here, and then we find a way to make 800. I like that idea. So you go here, you go here, remove that, and then we need to find a way to make 800. I imagine it should be possible to just add multiply 4 numbers together to make that, like 40 times 20 should do it. So that's like 5584. Uh, 5584. Or 25 times 32, as the kids say. I love multiplication when it works. Okay, so this is 99. We knew that. 5 times 5 is 25. We knew that. And 4 times 8 is going to be 32, and I'm pretty sure 32 times 25 is 800. You know why I'm pretty sure? Because 25 times 4 is 100, and 8 times 100 is 800. So yeah, there we are. Let's find a way to deliver that into the central square over here. Zoop. We probably no longer need 144. Nope. So we can cut you off and bring you guys over to overtake that thing. Nope. More nope. There. Okay. 899. Okay, let's do some more math. We also need 988, which is it's divisible by 3. I think. No, it's not. Yeah, because it's 1000 minus 12. Yeah, sorry about that. It's divisible by 4 though. So it's basically 250 minus, it's 147 times 4. 147, no, 247, sorry, 247 is not divisible by 3. Maybe we just make 1000 and subtract 12. Probably easier. Or we could like make 800 again. No, we can't make 800 again. That's a little bit too far away from 988. But we could make 900 and add 88. Probably going to be easy. We could, yeah, because 300 900 is like 30 times 30. Yeah. Then we need. Basically need the numbers that are around here anyway. Copy this and put it over here. Now remove these long tendrils. Okay, so we want to make 900, which is 30 times 30. So here is a 6, here is a 5. They are gonna be so happy when we force them to become 25 and 36 and multiply them together. Yes, okay, so that's 900. Then we need to make 88, which is basically these two added together, or multiplied together, like this and that. And is that the correct number? Yes, it is. Then we need to find a way to put it into the factory. Okay, do we need 189 anymore? Yes, no, we don't need. So we can steal... it at least doesn't need 2 belts. So, actually you can have that belt. You guys can come in over here instead. And this belt can be redistributed to now deliver these things instead. Okay, and let's just go back and double check we are producing the correct thing. 988 should be coming out there. Cool. And we get an upgrade. Nice, because we are just finished making all of the numbers we care about, so let's find some new numbers to care about. And 700. Boring. Yeah, we can do that. That's like 35 times 20. So we can do that pretty close to the base factory. We only need this part this time. Okay, so we need 4, 5, 7, and yeah, that's basically here. Donk, donk, donk. My god, I'm so glad I made this quadruple multiplication unit. It just makes my life so much easier. Now we're just gonna make 25 times 28 here, and that's 700. GG. Oh, it's so good to multiply like this. Are we needing either of these lines? 29. I don't think we need 29 anymore, do we? We do. 36. Did we need 36? We do. We don't need 2s anymore. We can remove this really unnecessary. We can remove this one as well. Okay, we have 2 free lines over there. So these 700s come over here. You know what? When I saw this game, the first thing I thought was like, okay, it's basically a Shapez clone, but it's math. So it's basically, I basically thought this is a game somebody made to just practice making a game, and they had like, we take the idea of shapes and we do math instead. But I really enjoy it. My brain really likes to solve these puzzles in how can I hit these numbers within the math available to me, and yeah, just making these double multiplication adders. Oh, it's so fun to make that actually work. And yeah, I'm a huge nerd, if you haven't noticed by now, but I don't think it's going to turn anybody away from that, because if you didn't enjoy this kind of nerdness, you wouldn't be watching this far into the series right now, right? Anyway, let's find another challenge to work on. Aren't we making 636? I thought we were making these guys, or are they just made so far away that we haven't delivered them yet? Math is one thing, but short-term memory is another. 6, 6, 4, 6, 7, 5, 6. Wait, 7, 5, 6. Why are we making 7, 5, 6? I think this is the one where we tried to make 636. What are the inputs there? The inputs are 30. The inputs are 30. And it should be 30 and 10. No, 30 and 20. Yeah, okay, so we have 2 lines of 6 instead of 2 lines of 5. We had 2 lines of 5, but we decided to use this 6, and that screwed everything up. Okay. That's just stupid, but sure. Let's just do this and scrap that part. Okay. Why didn't I notice that? Oh well. Okay, so now let's just clear this entire palette here. You are supposed to make 636. 636, yes, okay. Crisis averted, and with that, I will say thanks you guys for watching this episode of Beltmatic. I thoroughly enjoy this this game here. I didn't think I'd enjoy a game about addition and multiplication as good as I am, but there is something to there is a method to the madness here. Before we're doing anything, I just need to check how this divider here is working. So I'm thinking, I hope we can make fractions, but let's see here. Okay, so it's giving us the modulo of it, I think. Anyway, thank you guys for watching. It's been a Harbinger. We have been playing Beltmatic. If you want to try it out for yourself, the link is in the description down below. And yeah, I hope you enjoy this series as much as I do. Thanks for watching. It's been a Harbinger. I'll see you guys in the next one. Take care.